Hey guys, this video again is a part of the 50 Rust project playlist series. Now, in case you don't know about this, go to my YouTube playlists and there's a playlist called 50 Rust project playlists. And this is about the 23rd, I think the 22nd or the 23rd project in the playlist. This is, again, we're working with Ethereum here. And we built like very recently, like just the previous video to this, was a video where we did some basic functions with Ethereum using Rust, okay? But then in the same project, now this project exists on GitHub. Just want to tell you that it's already there on GitHub. Just go to my GitHub, Akhil Sharma 90, and then on that you can search for Ethereum. You'll find this Rust Ethereum project. So it's already there, right? So we did this simple transactions.rs file, and we also had some Solidity files in our examples folder. These files exist again on the GitHub, so you can copy and paste these in your examples folder. So using these examples, right? We hadn't used these examples in the simple transaction. We just created a balance. We just created an account, a wallet, and then checked out the balance and all those things and did some transactions. But today, what you want to do is we want to deploy the contracts that you see here, which are these examples, the ones that you see here. We want to deploy them to the blockchain, and that's what we'll be working with. Okay. Now, some of the code is going to be quite similar from this code, as in the sense like the first couple of things that we'll do will be quite similar. But what I also want to do is I want to show you. Now, the reason why I split this into two different videos is because I want to show you the output of this first, right? So that just makes more sense. Now the output for that is that you'll output the HTTP endpoint, the same thing that we did in the last video. Then we'll output the wallet first address. Then we'll also output the Ganache chain ID on the chain, the ID of the chain on which, like basically for Ganache. And then we're going to print out all the different Solidity files, all the different contracts. There's a contract called migrations, there's a contract called address utils, there's a contract called admin upgradability proxy, there's a contract called safe math. These are all different contracts that exist in our examples folder. So let me show you. In our examples folder, there are there's migrations, BUSD implementation, then there are address utils, admin upgradability proxy. All of these are the same ones that you see outputted here, right? So what we're doing is we're compiling all these contracts and we're printing out all of their data. Okay, so for example, for this contract, for proxy, for safe math, for upgradable proxy, you see all the data for all of these different contracts. Okay, that's what you see. All right, and in the end, you see data for a wallet first address, and then you see its balance. So we'll print that out as well, and we'll also print out for the BUSD, which is our BUSD implementation, this one. So for this one also, we will print out the data, like the contract address, right? So multiple things we're doing. So essentially, like if you chunk it down, if you put this into different chunks, what's really happening is you're printing out firstly all the different contracts that exist in that examples folder, the data for all of them. So that means you need a function that's able to print all of that out, right? So let me actually run this again with this extended thing. So it just looks a little bit neater to you guys. Okay, so the first contract we print out for is BUSD implementation, and then you have it for, then you have this line, then you have it for migrations data, then you have for address utils, there's no data there. Then you have for admin upgradability proxy, proxy, safe math, upgradable proxy. So you get data for all these contracts. So we're just printing them out. So we need a function. We need a function that prints out the data for that particular contract and then puts this line there so that so that we come to know when the next contract is starting. So it has to loop through these different contracts, and it also has to print them, and also has to print these lines after every contract. So we need something to handle that. And then we need we will be printing out the wallet first address and the balance of that wallet address, and then, like I said, the BUSD implementation contract address. Okay, so all of these things we'll print out. Now to be able to do that, what we'll do first is we will copy and paste some stuff from this file. So I need the first few lines. Okay, so I need all of this, like to print out the ganache endpoint. So I'll just copy and paste that here in my contract deploy. Okay, put some lines here for those use statements here on the top. And in the simple transactions, I also will create a local wallet, and I'll get the first address, and I will print it out also. So I'll just copy and paste this as well, the same thing from that function. Now what I also need to obviously create a provider. So what I'll do is I'll create a provider, and I will paste that here. Now using the provider, I want to get the chain ID, and I want to print that out. So to get the chain ID, what we'll do now is we'll say let chain underscore ID equal to provider dot get underscore chain ID dot. So with the help of the provider that we just created, you're getting the chain ID. Really straightforward. Await, since this is an async function, you can use await and get it as unsigned integer 64-bit. Right, and you'll just print that out. So as you saw in the terminal, first thing that you print out is the HTTP endpoint, which we've done. Okay, wallet first address we've done because we copied these two things from the other contract, from the other file, the RS file already. And this is the thing we want to print right now because we're getting the ganache ID, the chain ID, and now we want to print that out. Okay, so this is how you do it. So you print it out. Say ganache started with chain underscore ID and the chain underscore ID. This prints out the value of this chain ID, which is going to be 1337 in our case. All right, so now we start working with these examples. We want to compile these examples. We want to and then print them out. So first, let's compile them. We'll say project is equal to compile examples dot await. Okay, and then you want to print them out. So we've not created this function right now, the print project function. We will be creating it. So we'll say project dot clone dot await. Okay, so this print project function is something that we have to create together. It doesn't exist, and obviously the compile function also doesn't exist, so we'll be creating both of these functions. Now what you could do is you could here like put some space here, and you could actually keep some space there for the compile function. Okay, because sending the root directory and then all of the files inside it. So that's why we'll say root, which is going to be a string, and then you get back the result, which will be project compile output, and inside that will be configurable artifacts. And we'll just leave empty space right now for this compile function. Okay, the function that takes in the root directory, which is examples, and compiles all the files, all the smart contracts it finds inside it. Sorry, you'll keep hearing some beeps from my phone. It's only because I have to keep just a second. Sorry guys, I had ordered some food and that guy was just not able to find my house, so that's why I had to keep my phone on. That's why you could hear all those beeps. So he was trying to message me that he has reached the location, but his location was wrong. Anyhow, so coming back, now I've put my phone off because I've received the order. I've also eaten it. So we'll get back to the project. Okay, so the next function was the print project function. Okay, so fn print project. What does it take? It takes in the project. So let's say project is, in this case, project compile output and configurable artifacts. Then you get the result. And that's it. So we'll just keep the outlines of this function right now. Okay. And then work with the rest of the stuff. Now, we need to get some use statements on the top. So what I'll do is I'll just copy and paste and get all of these in from GitHub, from the code. So we're using hex to work with the addresses. We need standard path buff to work with the paths, because we are working with different folders, and in those folders we have these different files. We need time duration. We'll see why very soon. We need ethers to work with Ganache. We need ethers provider. We know why we're using provider, right? To get chain ID and to query the chain in general. We need IR to handle errors and that kind of stuff, right? So this is also the same thing, ethers. So we need all of this stuff, okay? Now we were here where we were compiling and then sending it to the print project. But it's obviously all in this is your main function, which is separate, and then you have these two different functions, okay, at the end, which is compile and print project. All right. So now what happens after you send it to print project? You'll just print those projects one by one. But then after you send it for print project, what you're doing in the terminal, if you see, after all these projects have been printed, you want to print out this wallet first address and the balance of the wallet, and also this contract address. So what we'll do now is we will say let balance is equal to provider dot get balance. Now my Rust analyzer is off at the moment. It's only because it's very distracting for me, at least when I work in Rust, and I only switch it on at the end to see if I've not missed anything. That's about it. I suggest you do the same, and then you print it out. You say wallet first address and the balance for that address. So we'll say wallet dot address dot encode underscore hex string balance. Okay, so essentially you would be able to print this part out, wallet first address, and then the address and the balance, the actual balance for that address. So you'll be able to print that out. Okay, that's what we've done here. Wallet first address, and it prints out the wallet address with the help of hex, and it prints out the balance, which is in the balance variable, because you got it with the help of the provider. Now let's take a specific contract from the list, which is this one, BUSD implementation. So we'll say contract underscore name is equal to BUSD implementation. Now I got these contracts from Zeppelin. OpenZeppelin is is on GitHub. It's a company. It's at least a project, like an organization on GitHub, which has all these projects, and they've created all these contracts for you, like SafeMath. Basically, if you're using Solidity below 0.8 and you don't have and maths, there's a problem for integer overflow or underflow, which is a problem with all the lower versions of Solidity. You can use SafeMath there and not have that problem. So basically these kind of contracts which help you to work with Solidity, they've already created for you, Zeppelin guys, and they've kept them in that repository in their organization. So you can check them out in case you don't know about OpenZeppelin. So I'm just giving an example about what SafeMath does, but then all of their contracts have use cases. So for example, they also have the official implementation of ERC20 token, ERC721 token, and so on. Very useful stuff. And in Solidity, you can't really build without using OpenZeppelin. Okay, so they've kind of made themselves very important there. I'll be teaching Solidity also if possible, if I get some time. I like Solidity as well. I'll try to teach it if I get some time. Okay, so let contract is equal to project, and then you find the contract name, context, contract not found. So the contract we're trying to find is BUSD implementation, this contract, and we'll try to, from the project being after you've compiled all the examples, you want to find a particular contract, and if you don't find it, you'll say contract not found. Okay. Now from the contract that you found, after you compile a contract, you get something called as ABI and bytecode, two different things that you get from a Solidity contract. So let's just extract those. So we'll say that ABI is equal to comma and bytecode, ABI comma bytecode comma underscore equal to contract, which is this contract here, which you found right now, which is BUSD implementation, dot into parts. Okay, and remember, this is the compiled contract. Only if a compiled contract can have ABI and bytecode. Otherwise, you just get the Solidity code. That's it. You don't get ABI and bytecode. So you get ABI is equal to ABI dot context, say missing ABI from contract. Okay, so if you were not able to find ABI, so firstly, if you did find ABI, you'll assign it to ABI. Otherwise, you'll just say you didn't find it. And similarly, let bytecode is equal to bytecode.context, and let's say missing bytecode from contract. Okay, and now you'll deploy the contract first. So to be able to get this right, let me show you. To be able to get the contract address, you need to deploy that address somewhere, and only then we'll get the contract address. So let's deploy it. So we'll use our factory, let's say contract factory. But before that, we have to create a signer client. Okay, so before you start deploying it, you need a signer client. So you select wallet is equal to wallet.with chain underscore ID, and let client equal to signer middleware. Okay, signer middleware you get in the providers itself. So I just want to create a type called signer deployed contract here. Contract, and I'll use same signer middleware, then the provider, and then the local wallet. And coming back here, I want to create my client. Okay, the client is signer middleware new, and use provider dot clone wallet. And now that you've signed, okay, now that you've created a signer client, you'll use your contract factory to deploy it. So you'll say new ABI dot clone comma bytecode. You need the bytecode and ABI to be able to deploy it, and you'll use this client that you've created to be able to deploy that contract. Okay, so here you can say deploy contract, and here you can say create signer client. Without that, you can't really get it. And here you can say get ABI and bytecode, which are only available in a compiled contract. Okay. Now I'll create a variable called deployer, and I'll say factory dot deploy. Okay, so this is the main function that helps us deploy with the entire factory. So factory has ABI, bytecode, and client, and deployer enables you to deploy with the help of factory.deploy. I will say let block equal to provider dot clone dot get underscore block number playlist dot await and dot context failed get block. Okay, so after you deploy, you also want the block number, and you can use this provider dot get block where you get the latest block number. And if you're not able to do that, you'll say fail to get the block. Now you'll have to set the a reasonable gas price. Okay, so to be able to deploy it, you'll need to set a reasonable gas price. We'll say gas price equal to block dot next. So you want the latest block, and then you want to say for the next block, because our contract is going to the next block. So I'll say next block base fees dot context and fail to get the base fee for the next block. Then you have deployer dot transaction dot set gas price and U256 gas underscore price. Alright, so you created a signer client, you deployed it, and to be able to deploy it, basically you first need to get the latest block and then set a gas price to be able to get your transaction to the next block, and you send that gas price there after you get the gas price for the next block. And then you'll say the contract equal to deployer. You have your deployer here, which is basically factory.deploy dot clone dot legacy dot send dot wait. And now that you have the contract, now this is when we are saying the contract is equal to deploy dot clone dot legacy dot send, is getting us the deployed contract in the next block. Okay, and here we're going to print ln the address of this deployed block. So you're going to say bust implementation contract address is, and we'll obviously have to use our contract object. So you'll say contract dot address dot encode hex and string and here you'll say okay. So that's the entire picture, right? That's how you will deploy the contract and get the contract address. Okay, I'll repeat again. I'll take you through the whole main function again. So we create a mnemonic, create a Ganache, spawn off a Ganache instance from it, and then we'll print out the Ganache endpoint. So these three things we have seen in the previous video as well. Create a local wallet with the help of Ganache. Okay, and then the first address you get from the wallet, and then you print out the wallet first address. We've seen this also in the previous video. Create a provider. We've seen this in the previous video already for the Ganache endpoint. Provider helps us to query the Ganache endpoint, Ganache being our local blockchain. We want to deploy these contracts on our local blockchain basically. The chain ID on which we have to deploy. So let's get the chain ID first. And we can print it out. Ganache started with chain ID. So here, when you see in the terminal, when you see it in the terminal here, you see it's gonna start with chain ID 1337. Awesome. Then what you want to do is you want to take a variable called project, compile all the examples in the examples folder, all the files in the examples folder, all the contracts, and you want to print them out one by one. Okay, so you print all of them out. Now we have to obviously create this function to print out all these projects. The next thing, now when that's happening, after you print out all the projects, where you can see here, let me show you. You print out all of your projects. And then after that also we do something else. We print this out, right? For wallet first address. So let's see how we did that. So for that we said let balance is equal to provider.get balance, and for wallet we sent an address and we just printed out wallet first address. That's it. This is the code that prints out the wallet first address. But then we also want to print out, after deploying one of the all the contracts are compiled. We have the ABI and bytecode. We want to deploy just one of the contracts, like let's say the BUSD implementation contract, and deploy it to the local chain ID 1337, and we want to get the contract address for it. So how does that work? What we do is we take a specific contract name, we search for that contract in our projects, which is project, if you remember, is all the compiled examples, and then we get the ABI and bytecode from that contract. Now once you have the ABI, you assign it to this, you get the bytecode to this, create a wallet, create a client, okay, to be able to sign those transactions. When you have these transactions, when you're deploying is also a transaction, you want to sign it, you need a signer client. To deploy it, you need factory, contract factory, and then you create a deployer, factory.deploy, and then to get the block, right, the latest block, you use your provider, and to get the base fee for the next block, you use a variable called gas price. Again, you use block for that, which is essentially your provider, right? And deployer that you have created here, factory.deploy, transaction set price, set the price for that, and then your contract will be able to access it with the help of deployer. Okay, because it's deploys the contract, and it gives you the contract object where you'll get the contract address, and you can use hex to convert it to string and print it out into the terminal. So this is what your main function does. Now you have the compile function and the print function to complete. Okay, so the compile function, what it does is it makes a lot of use of the path buff that we imported earlier, because it has to go through these multiple paths, right? How does it do that? It says let root being the examples folder that we have sent to it. If you look here, we are sending it the examples root. Okay, so we'll say let root is equal to path buff from root, and first we will say if root does not exist, turn error, and you use IR for error handling. Say project root does not exist. Awesome. Now the next thing is you configure root as our project's root. So you'll say let paths equal to project paths config builder, and you'll say dot root ampersand root dot sources ampersand root dot build. Then you'll create a Sol-C project builder. So it'll say let, to be able to compile it, you need Solidity compiler, Sol-C. So let's do that. So it's let project is equal to project dot project builder dot paths dot set auto detect true and dot no artifacts dot build and then you compile that. So you set, once you created the project, then you compile it. So you set output equal to project dot compile. And you check if the output has some compile errors. So whenever you have a Solidity file, you use, like I said, the Solc compiler, and then you compile it, and then you might also get some compilation errors, and that's what you want to handle. So you said has compile underscore errors, and use higher again. Compiling Solidity project failed. Output dot errors. Okay. So if you have any compile errors, you'll say compiling Solidity project failed. Otherwise, you just print out the output. All right. So everything, you just send the output. Okay. So everything is everything seems to be fine here. Obviously, we'll switch on Rust Analyzer in a while. But the other function we want to do is that the function that basically prints those projects. So we'll say that artifacts equal to project dot into artifacts, and we have to loop over all these projects to be able to print them. So in the terminal, when you saw all of these projects, I had mentioned that there's some way that you're looping over all the projects one by one, all the contracts, and you're able to print them out. So we need the ability to loop over them. So let's say for id artifact and artifacts. Okay, and here we'll say let name is equal to id.name, and then let ABI equal to artifact dot ABI dot context. And if you didn't find any ABIs, you'll say no ABI found for contracts, or sorry, for artifact, and you'll print out the name. And now we're going to print that those lines that come up after every single contract. So let's print that out. So here we'll put is equal to. So if you look closely, basically the output is equal to, right, this line that divides these different contracts. So we'll say that is equal to dot repeat and 80. Print ln contract name. Okay. Finally, you say let contract equal to ampersand ABI.ABI, and let functions equal to contract dot functions, and let functions equal to functions dot cloned. Let constructor contract dot constructor. Then if let sum constructor let arguments equal to ampersand constructor dot inputs. Constructor arguments and then lastly we'll say, so finally we'll say okay here, and lastly here we'll say for func in functions that name is equal to ampersand func.name, and let params equal to ampersand func.inputs, and print ln function name and params okay. So that's our entire program. So I've taken you through the main code once. Now let me take you through the compile function and print project. Maybe because I was a little more involved in writing this down and not like typing this out and not making any mistakes. I was really consumed with that. So let me explain to you now. So compile, what you do is you create path from string. Okay, create path from string, which is the root that you've passed here, examples. And you create the path in root, and then you check if that path even exists or not, right? So otherwise you'll say that project root, which should be root here, does not exist. And then what you'll do is you'll configure the root as the project's root, okay? And then you'll create multiple paths from it. Then you will create a solc project builder instance. So this is a solc project builder instance, and here with this function you basically auto detect the solidity versions. For example, it could be different in this file, could be different in this file, right? Even though right now they're same, but they could be different. So that's why we have this function here to auto detect the solidity version. Now we need the solc compiler, like I mentioned to you, solidity compiler, to be able to compile these solidity files, and that's what we're doing. Okay. Finally, you compile the project and you get that in a variable called output. Now we check the output for compilation errors. If there are any errors, we use the IR library to print out those solidity errors, those compilation errors. If everything went well, we just return the output, and this is what it returns, right? Project compile output, that's what it returns. Similarly, the print project function, you are essentially printing out the contract, constructor arguments, and the function, and this can be seen very easily in the terminal, right? You can see the functions being printed out, right? The contract being printed out, and the functions for that contract being printed out, and the construction arguments, right? So when you look at the output, everything just makes sense. Constructor arguments, the functions, and the contract, these three things, we're printing them out, and that's what essentially we're doing. So we want to print the contract out, the constructor arguments, and the function. To do that, what we're doing is we're starting with this whole big for loop that goes over the artifacts, right? So you have project, you divide the project into artifacts, you got all the after effects, you went with that artifact one by one and went over them. By artifact, you're basically saying every single project. So you compiled everything in examples, and all of these projects will be different artifacts, right? And you want to capture them one by one, and you want to print them out one by one. So that's what you have. So you're doing that one by one. So you'll print out the ID and the ABI, and then you'll put out that line, and then you're basically printing out the contract name. So before the beginning of every contract, you'll have a line. So when you see that the first thing that you print out is the line with the help of this is equal to sign. Then you print out the contract name. See that contract name being printed there. Then you get the contract and the functions and the constructor, all of that, and then you print out the constructor arguments. Then you go over all the functions. One by one. So in the functions, you will select function in func one by one, print out the function name and the inputs and the names and params, and that's what basically we're doing for each function, right? We're printing out the params one by one and so on, right? So that's what our entire program is doing. So some of these programs are complex and I know, but they require patience, right? So if you are patient, you follow this video to the end. I always explain everything. It can be overwhelming to build the project in the beginning. Now I've switched on Rust Analyzer. Let's it's going to give me obviously a lot of issues, and many of them will be like these, where I'm messing up the spelling. So you have messing up the spellings basically in many places. So here I'm sure there will be few issues. So I'll see. This looks all right to me though. Okay, so we'll have to go through all of these issues one by one and solve them together. So firstly, this one looks easy to solve because I have to put a dot here, which I've not. So this one looks easy to solve, but I still have 9+ issues. So there's still a lot of issues that we need to solve. All right. In many of the places, all that's missing are these semicolons. So I'll just put these quickly. Semicolon here and semicolon here, right? And then this should have been compiler errors. So just like simple issues like these that are basically creating issues. So I'll just quickly fix them. The fixed code, guys, already for you. It's there on GitHub. So I'll fix these quickly, and we'll then compile it fast. On this line, the issue that you see here is because I missed a question mark here, right? And it's just basically small issues like that, like semicolon here and question marks here. So I'll just fix it and we'll just start compiling it right now. And we have literally one issue remaining, and that's coming on this line somewhere, avi.avi. And that's also happening because I missed a question mark at the end. All right, so now we're clear. We can start compiling now. So here, I'll go to my terminal. I'm in my YT project, which I created for you guys, Ethereum YT, and cargo run bin deploy. Obviously, it'll take a lot of time to build this new one, the deploy file. And then as expected, it prints out everything that we want. So wallet first address, BUSD implementation contract, output of all the contracts with their functions and their parameters, function parameters and the constructor arguments, the constructor arguments, the name of the contract, all of that basically. And then ganache, on which chain is it working. Right, guys? So I hope you learned quite a bit in this video. And now the next video that I'll make, we'll go back into Web 2. So it won't be Web 3 anymore. Just wanted to give you like a quick Web 3, tour with Rust. Because we've done, I think, Solana on this in this series. We've done Polkadot. I also want to show you how you can work with Ethereum with Rust. And even if I create another Web3 video, it'll be like showing you Foundry, because I really want to show you how Foundry works, which is exactly what we have built. But Foundry just does this like much more efficiently. It's a complete framework to compile and build and also deploy contracts, right? And it's completely in Rust, and it works on these Solidity files. All right. So thanks a lot for watching, guys. I hope you've subscribed already, because you get content here which you don't get on other YouTube channels. And do subscribe, share it with your friends. Awesome knowledge here, a lot of things to learn. So thank you for watching. I'll keep making awesome content like this. Thank you. See you.